Hello, and welcome to Group 3's presentation of the Sociotechnical system. This theory is presented briefly in Chapter 7 of Richard L. Daff's textbook on organizational theory and design, and is presented by the following individuals: Casey Barnes, Camilla Kunjan, Nikki Culver, Eric Dukes, Michael Sanders, and Anne Catherine Uhi. Our presentation will take a deeper look at the sociotechnical system by discussing the following topics. What is the sociotechnical system and its three components? We will then examine the history of the system, who first promoted it and its early uses. Then we will look at companies and industries that have used the system well and poorly. Then we will explain how the system has changed and evolved over time. Next, we will evaluate the system and its results. And finally, we will conclude with a summary of key points and questions for discussion. With that, let us begin. What is a sociotechnical system, or STS for short? A sociotechnical system is the interaction of technical and human needs in effective design, combining the needs of people with the organization's need for technical efficiency. The basic premise is easily understood, an idea that most of us implement on a somewhat daily basis. For example, in preparing for this presentation, our group has implemented the beginnings of an STS. We had to combine the needs of our individual group members with available technologies of audio recording and PowerPoint to create a presentation for this class. If our group were to continue making presentations, we would constantly assess the needs of the group members and the available technologies in order to optimize our presentation. The socio-technical system is broken down into three distinct parts: the social system, the technical system, and joint optimization. What is the goal of a socio-technical system? The goal of a socio-technical system is to combine human resources and technologies in the best possible configuration that optimizes the company's production. This process is always being refined with advances, primarily with technology, but also as social systems change among different age groups or countries. We will now take a look at each of these systems individually. Social systems. Social systems are, simply put, the people and groups that work in the organization and how the work is organized and coordinated. Social system components include individual and team behaviors, organizational and team culture, management practice, leadership style, degree of communication openness, and individual needs and desires. In short, components of the social system deal with all aspects of the company or industry that relate to the human side, from employees to customers and end users. Technical systems. Technical systems are the materials, tools, machines, and processes used to produce manufactured goods. Technical system components include the type of production technology, level of interdependence, physical work setting, complexity of the production process, nature of raw materials, and time pressure. Similar to the social system, technical systems deal with everything apart from the human side that is needed in order to produce goods and services. Now that we have taken a look at social systems and technical systems separately, we will now briefly discuss joint optimization. As we have stated before, joint optimization is the combination of the social system and the technical system that results in an optimized production environment utilizing the best of both resources available to the company. Some final notes about joint optimization. Point 1. Joint optimization is always focused on the goal, not how that goal is achieved. This allows managers and employees flexibility to tailor their mix of human and technical resources in order to achieve the stated goal. Point number 2. Joint optimization lets individuals take responsibility for outcomes and can make decisions autonomously. The idea of joint optimization is not to eliminate the need for human input, but rather to provide a roadmap for managers to utilize in order to maximize the results in the best way that they see fit. And finally, point 3. Joint optimization is adaptable to changing technologies. As technologies improve, the socio-technical system will necessarily change in order to optimize results.
In this section, I am going to talk about the origin of the socio-technical system method. The socio-technical system was created by Eric Trist. Eric Trist was a British scientist and leading figure in the field of organizational development. He was one of the founders of the Tavistock Institute for Social Research in London. The Tavistock Institute of Human Relations, or THUR, is a British non-profit organization which applies social science to contemporary issues and problems. Trist and his associates at the Tavistock Institute in the UK are well known for conducting a series of studies that led to a new and insightful approach to understanding organizational functions. These studies, which focused on the coal mining industry in the UK, examined the interaction of technological systems and social systems. As technology advanced, newly developed mining equipment dictated a radically different approach to coal mining. This new approach was named the longwall method. In this new longwall method, the miners were reorganized into large shifts of specialized workers. During the first shift of the day, all miners performed the same operation, cutting into the coal wall. The second shift was responsible for shoveling coal into a new type of conveyor. The miners on the third shift worked exclusively on advancing the face of the wall, enlarging gateways, and building roof supports, relatively low prestige tasks. In addition, the miners on each shift were spread out along the face of the wall at such distances that they could not easily communicate with one another. Similarly, the single supervisor of an entire shift group consisting of 40 to 50 miners was not able to monitor the activities of each miner because of the manner in which the men were dispersed. Although the longwall method promised to raise productivity, a norm of low productivity emerged. With the reduced variety and challenge, the miners found the redesigned work to be unpleasant. They preferred to operate autonomously and to perform all tasks rather than solely performing the task of cutting, shoveling, or filling. Trist came up with 3 key takeaways from his study, including responsible autonomy, adaptability, and meaningfulness of task. Responsible autonomy is a principle that suggests workplaces should give workers more control over their work. Adaptability means that workplaces should be flexible, for example, by changing up tasks and schedules. Meaningfulness of task means employees should perform a diverse array of tasks to decrease repetitiveness at work. While the Tavistock researchers eventually helped to ameliorate the negative consequences of the longwall method, the message was clear. A technological change that appears quite rational from a purely engineering perspective can disrupt the existing social system so as to reduce greatly the anticipated benefits of the new technology. Of more fundamental importance is the insight gained by the Tavistock researchers on the interplay of technical and social systems, or the notion of a socio-technical system. Attempts to change the technical and/or social system must be mindful of the relationship between the two systems. The socio-technical approach had much to suggest to job redesign. In fact, the approach had been employed in numerous job redesign efforts. Some of the better publicized redesign efforts had been attempted at General Foods, Rushden Mining, and General Motors. At the Calamar plant of Volvo, automobile assembly procedures were radically altered from traditional technological systems. By and large, the results of these efforts have netted reduced turnover, absenteeism, and accident rates, and increased superior product quality and efficiency.
Now that we've talked about the history of socio-technical model, we're going to take a look at what that looks like in action. As my teammates have discussed, over the last 50 years, there have been an abundance of attempts to implement a socio-technical model into business. In those attempts, we can see that there were both positive and negative results. In this section, I will cover some of the applications that went well, what did not, as well as what type of industries and companies a socio-technical system works well in. So, what went well? Through the successful implementation of a socio-technical system, we see an expedited production and assembly time, as well as identifying a greater span of risks and vulnerabilities. Brune and Van Eaton, one of the researchers that we found to have a lot of work done on the socio-technical system, explained this saying, a socio-technical system perspective can prove it advantageous when performing risk and vulnerability analysis, since it makes it possible to identify risks and vulnerabilities that exist not only in the social system domain or the technological system domain, but rather in the interaction of those two domains. What did not work? The biggest failure we see with a socio-technical system is in the commitment of implementation. If there's not a full commitment and there is some sort of inflexibility, personal relationship in the way, or a risk aversion to adapting to a new system, we see the socio-technical system doesn't get off the ground. There is too much pushback, and the socio-technical system just doesn't get the chance to begin operating in an optimal way to actually produce results that are positive for a company. 4 industry types that this model works very well in are the automobile industry, manufacturing, technology, and critical infrastructure. To explain this a little more, we'll take a look at Volvo's implementation of it into the automobile industry and then at critical infrastructure. In the most popular case, which is Volvo, the change to a socio-technical system had a radical impact on the organization's methods. The production line, which had been used in automobile manufacturing since Henry Ford first implemented it, was removed. It was replaced by an autonomous group work undertaken by well-qualified personnel. The parts for the cars were organized as if they were kits, which each member of the team completing a proportion of the kit and the team as a whole effectively building a whole car. This was independent of other teams which were also working on their own kit. This required less time and less costs in tools and training compared to similar plants that were organized around a traditional factory principle. The other large industry that I'm covering is a critical infrastructure. This may not be a traditional industry thought of in dealing with socio-technical systems, but a handful of Swedish researchers are making the push to include socio-technical models into critical infrastructure. You're probably wondering just what is a critical infrastructure. Well, the following definition comes from the first version of the U.S. National Plan for Critical Infrastructure. Those systems and assets, both physical and cyber, so vital that the nation that their incapacity or destruction would have a debilitating impact on the national security, national economic security, or national public health and safety. A handful of types of critical infrastructure in which we can deploy a socio-technical model are electrical power systems, transportation, emergency services, and continuity of government. You're probably wondering, why would a socio-technical model work here? Brune and Van Eaton suggest that the hazards of socio-technical models might be fundamentally due to either the societal system design and the interactions of a societal and technological system. This indicates that an analysis that spans both the technical and the societal domains is advantageous for identifying the vulnerabilities of our society, which is what you're trying to do when you're managing one of these critical infrastructures that has so much impact on our society and the day-to-day lives of our citizens. There are many company types that can benefit from the implementation of a socio-technical system, but to highlight a few, companies that are going through technological change and need to implement some sort of new technology, companies that are focused on increasing efficiency and are looking for new ways to do that, and companies that rely heavily on technology in day-to-day functions, like an engineering group or the Digital Equipment Corp, which we'll talk about in a minute. The Digital Equipment Corporation is one of the world's largest computer manufacturers. In 1986, it employed 670 people and shipped around $500 million of systems. The site in Scotland was the final assembly and the test of systems for European markets. This involved configuring systems, testing, and other consolidation. Why would they make a change to a socio-technical system? Well, a capital-intensive automated manufacturing process could have reduced unit costs, but only when high production volumes were reached, and this cannot be guaranteed in an unpredictable market. An automated process would not be able to cope with the rapid and fundamental changes in the product technology, such as a move from a dual inline packaging to a surface mount technology. Manual assembly with standalone automated equipment was less expensive, less risky, and less flexible, and therefore it was a better fit for the business. So, a socio-technical system was implemented.
In this section, I'm going to talk about how new technologies have changed the system and how the system influences cultural dynamic. The domain of socio-technical system isn't just about how people interact with pre-existing technologies, but also about how organizations adapt and evolve with new technologies. And there are always some people that fight against the new. Let's take a look at important technologies that have been invented since the inception of the system. In 1967, video games were invented. Since the 70s, we have cell phones and GPS systems. CD players were brought onto the market in 1982. In 1989, the internet was discovered. And the last two main inventions were the Wi-Fi in 1997 and touchscreens in 2007. After listing all those new main technologies, now consider the effect that these technologies had on human work in the system. I am sure that when the GPS system, for example, was invented in 1978, some workers would reject it and still use maps instead of the modern GPS system. For an easier implementation into the system, one has to consider the perspective of multiple stakeholders, training for new operators, the integration of the subsystem, and the process into the whole system. Sometimes people reject new technologies due to cultural beliefs. This is the case when a new process doesn't fit in with society's beliefs, values, and religion. Examples are biotechnologies, nanotechnologies, artificial intelligence, and cognitive technologies. Many people have been rejecting biotechnologies, and here's an example why. Human testing is a commonly used concept in biotechnology. In 1999, the 18-year-old Jesse Gelsinger died while participating in a gene therapy trial at University of Pennsylvania. The young boy had joined a trial that was aimed to develop a treatment for infants born with severe disease. The professors had known that in previous trials, participants had experienced severe side effects and 3 monkeys had died. Nevertheless, they let Jesse Gelsinger test this dangerous medication. To every new technology, there will always be an ethical consideration. Either people reject the new technology or they adopt it. And if the technology is adopted, people might or might not be able to integrate the cultural dynamics of it.
Hi everybody, I'm Mike Sanders. Before we start talking about the evaluation of the socio-technical system model, first I'd like to commend you for making it this far into the presentation. So far, we have talked about what the socio-technical system model is, the 3 components of the model, the history of the system, what companies have successfully used the system, how the system or model has changed and evolved since its creation, and now we're going to talk about the evaluation. To evaluate the STS model, we're going to answer 3 basic questions. Does the STS model produce meaningful results? What are the benefits of the STS model? And what are the hazards of the STS model? At this point, we have already discussed that the STS model is capable of producing meaningful results. STS was a standard of manufacturing for decades. Several companies were able to successfully achieve joint optimization with great results. Rather than employing a strict mass production assembly line similar to how Henry Ford revolutionized industry, the companies broke the assembly line into semi-autonomous units and empowered the workers with the appropriate tools and technology. In our picture here, we see a couple of happy workers using technology to build their widgets. So to answer the question, does the STS model produce meaningful results? The answer is yes. It can produce meaningful results if properly employed. So why hasn't every company adopted the STS model? Following World War II, manufacturing in Japan was devastated, and it was difficult for Japanese companies to secure adequate levels of capital to recover their pre-war manufacturing capabilities. Out of necessity, lean production was born. Waste is a sworn enemy of lean production. Every action in lean production is carefully analyzed to determine the absolute most effective way of doing the action. The Japanese companies did not have the time, funds, or patience for the STS focus on optimized employees and technology. Instead, their workers and technology were pushed to continuously improve their efficiency. While this approach potentially has some negative effects on employees, it also produces improved results, including bigger profits. By the 1980s, many Japanese car companies were the embodiment of efficiency, and by the 1990s, the rest of the world was ready to commercialize lean production, which is why now project managers all over the planet strive to earn a Lean Six Sigma belt or some other such certification. In our picture here, we see our once happy worker is depressed because her push-button widget maker is now deemed inefficient. Lean production became the in thing for industry right as the information age was beginning. And in this transition, the STS faded away into the halls of academic theory. Or did it? While researching for this presentation, I came across a number of peer-reviewed articles about the emerging comeback of the STS model. Most tout low employee satisfaction and high turnover with lean production. There have been efforts to combine lean production and STS with mixed results. Ultimately, it seems that companies are noticing a correlation between worker satisfaction and productivity, which is causing STS to once again become back in style. The benefits of the STS model all seem to center on the idea of creating a stable work environment that adapts to changing technology. STS is a long-term strategy in which companies empower and retain good employees. This results in increased longevity for workers and their technology. It reduces the downtime due to equipment breakdown or injuries because the workers are invested in the appropriate protocols. They're the ones that help create them. Finally, it makes the integration of new technology easier because the semi-autonomous work environments are geared towards joint optimization in the first place. For example, look at how well our little happy employees are doing with the addition of a robot. STS isn't perfect. No model is. Both the people and the technology aspects are bound to have issues from time to time. STS doesn't have the same unrelenting focus on continuous improvement of efficiency like a lean production would. So the short-term setbacks, such as waste and reduced profit, may occur. But it seems that where STS struggles in the short term, it makes up for in the long run.
Hi everyone, my name is Nikki, and on behalf of Group 3, I want to thank you so much for joining us through this journey as we discover the Sociotechnical Systems method. We know that this is a lot of information and concepts, so we appreciate you hanging in there and making it all the way to the end. The final portion of our presentation is going to be a recap of what you've already learned and how sociotechnical systems can apply to your life. One of the most important takeaway points is the actual definition of socio-technical systems. If we break the word down, we can see that socio means people and technical means technology. When we combine them, it means people and technology. So socio-technical systems are literally people and technology systems joined together. The goal of socio-technical systems is joint optimization. Joint optimization is when people and technology systems are designed to work together and meet the needs of one another. This method moves away from dollar signs being the primary gauge of success and takes into consideration the well-being of the people utilizing the technology within an organization. As with any organizational system or method, there are always advantages and disadvantages to development and implementation. One of the issues that often arises when an organization tries to use socio-technical systems is the misunderstanding of the definition. It is important that everyone working on developing or implementing a socio-technical system is operating with the same understanding of the word and the goals. The advantages that come with using socio-technical systems include happier and healthier employees, lower turnover, which results in lower expenses, a free exchange of ideas, flexibility, and increased productivity. A disadvantage to socio-technical systems is that it is dependent on the users. If there's resistance to the system, it will not work like it should. This is why it is so important that an organization has a good team with a clear understanding of the concept before they embark on implementation. If a socio-technical system can be effectively implemented, then it will reduce situations that negatively impact the people using new technology, like taking someone's office to make way for a photocopier. Up to this point, we have discussed socio-technical systems on a large scale. Historically, the socio-technical system method has been utilized in huge industries like manufacturing, the auto industry, and critical services like government and emergency services. But these concepts can be applied to smaller businesses and entities as well. The benefit of socio-technical systems is that they are designed to adapt and remain flexible as technology and people change. This means that there is an ongoing analysis over time, and an organization can change in order to meet their goals of joint optimization. Small businesses can be structured with a socio-technical system method mindset and benefit just as much from those core concepts. For example, using file sharing tools like Google Drive and Dropbox is a great way to bring people and technology together to function at a more efficient capacity. Collaboration software is also available, so using communication apps like Slack or Zoom are also examples of socio-technical system principles being put into place. It enhances an employee's ability to do their job well and connect with one another utilizing the most current technology available. It absolutely doesn't have to be all or nothing with socio-technical systems. Different organizations have different goals, but finding some balance between people and technology can benefit any business or entity in the long run. Now that we've seen socio-technical systems in regards to huge corporations and smaller businesses, the question remains, where do you see socio-technical systems in your everyday life? I can almost guarantee you use them. Social media is a great example of socio-technical systems at work. Facebook, Instagram, Twitter, Snapchat, LinkedIn, and Pinterest are all examples of technological platforms that bring people together and increase communication. As technology continues to develop and we find itself making its way even further into our lives, we will see more socio-technical systems established. A great example of this is remote work or teleworking. Allowing an employee to work from home, another state, or even another country can greatly improve their quality of life while still resulting in high productivity and profits for a business. There must be a system in place to facilitate and manage that type of arrangement, and more than likely it will look like a socio-technical system. The flexibility and adaptability make a socio-technical system ideal for organizations that are dependent on technology or work closely with it for success. So how about you? Where do you see socio-technical systems in your life? If you could recommend a change in your life, whether it be work, school, or personal, to create more of a balance and reach joint optimization, what would that change be? How would you go about making those changes, and who would you need to bring along with you? Remember, resistance is one of the leading causes for socio-technical systems to fail. Think about how you can utilize some of these concepts that we've gone over to improve your life and create the balance to reach joint optimization. As we wrap up, I would like to remind you that one of the greatest benefits of socio-technical systems is their flexibility and adaptability. As technology continues to evolve and take a greater role in our lives, it is important to remember the human component of business and efficiency. Socio-technical systems acknowledge that relationship and strive to create harmony between people and technology. You now have some opportunities to test what you've learned and share your insights on socio-technical systems. We have developed a fun quiz for you to take. This quiz is set up so you can compete with your classmates for the highest score. The quiz has a countdown, and the goal is to answer as many questions as you can in the time allotted. All of the answers to this quiz questions can be found in this presentation or in Chapter 7 of your book. When you go to take the quiz, be sure to create a free account so your score and rank in the class can be tracked. Additionally, we have developed a fun bingo game for you to partake in. We have emailed everyone a unique bingo card. You can find this in the email associated with your Blackboard account. Be sure to print off your card, mark down your squares, and then post a picture of your card to the discussion board and shout bingo when you've filled in all of your squares. And finally, we've put out a discussion question on the class discussion board that is designed to kick off the conversation about socio-technical systems. Please join us there with your experience and thoughts on the socio-technical systems and their applicability to your life. Group 3 would like to thank you for watching our presentation. We are proud to share socio-technical systems with you and look forward to seeing you in the discussion board. Thank you so much for the time and energy you have put into this class, and we hope you enjoyed the presentation. Stay tuned because the bingo game is coming up next.
Thank you for your attention, and now Mike is going to talk about the evaluation of the system.